so on the first read, starting with number 11. Okay, so it said, according to a survey, 18% of Americans trust organized religion. So what would be the probability that a random person selected would trust organized religion? 18%. B, the probability that they do not, that's just the complement, so 1 minus 0.18. 0.82. C, would it be unusual for 3 random Americans to all trust organized religion?
Yes.
Okay, how would you find it? You would have to support your answer somehow. Okay, if I'm just picking 3 random people, it's the first trust and, the first one trusts and the second one and the third one. So you could just multiply those, or that's just 0.18 to the third because they are independent, and you get 0.005832. And remember, unusual is less than 5%, so that is unusual. So D, the probability that in the sample at least one does not. Okay, at least one not trusting could be the first one doesn't and the others do, or the second one doesn't and the others do, or the third one doesn't and the others do, or the first and second don't and the last one does, or are you getting the idea? There's a lot of combinations. But it's everything except the scenario where they all trust. So it's just a complement of part C. And so if we subtract those, we get 0.99416. Is that okay? Number 12. All right, so we have 12 cans of sauce in our case. And we know that 5 of them are traditional and 7 of them are meat sauce. And nothing has a label. Okay, so you guys were good with A? So B, what's the probability that exactly 2 are traditional? So think about all the scenarios. We are taking 3 random cans. So it could be all 3 are traditional, or the first 2 are traditional and the last one's meat, or first and last traditional, the middle one meat. So I am listing, what's this called when you list all the possibilities? Sample space. That would be a good question on the test. It would. So if we're listing all of our options here, what do I have left? I've got all the cases, so we're just missing when they're all meat. So it wants probability that exactly 2 are traditional. So if I'm looking, that could mean the first 2 is traditional and the last one's meat. First and last are traditional, or the second and third are traditional. So I have to basically find those 3 probabilities, add them together to answer this question. You guys okay with me here? So the first one being traditional, there are 5 out of the 12 in my case. But if I take out a traditional, what's the probability the next one is traditional? Now there's 4 out of 11 in the case. Okay, if we took out another traditional, then the probability of getting meat at this point, there's still 7 meats, but how many cans are left? 10. Alright, next one, traditional. So there would be 5 traditional out of the 12 total. If we take out a traditional, we have 7 meats out of how many cans? 11. Okay, if I took out a meat, now there are 4 traditional out of the 10 left in the case. Okay. Or the last option, the first one being meat, that would be 7 out of 12. Next one being traditional would be 5 out of 11. And then 4 out of 10. You guys understand where I got all of those? So then we just put it in the calculator and we get 0.3182. Let's see. So the probability that none of them are traditional. If I look at my sample space, the only case with nothing traditional is the case where they're all meat. So if we think about this, probability of getting a meet for the first one would be 7 out of 12. If I took a meet out, the probability of getting meet on the second one would be 6 out of 11. And to get it on the last one, that would be 5 out of 10. You get 0.1591. Any questions on that one? Right, 13.
Oh wait, I have a question.
Uh-huh.
So on 12B. Oh, so wait, never mind. Okay, I understand.
Are you sure?
Yes, I'm positive.
Anything else? All right, so problem 13 is talking about the 3 different types of probabilities. So, subjective. Subjective is based on personal opinion. Okay, they're probably basing it off something, but 2 people might disagree. So it might be like the weather. You know, if you check one weather station, it says there is a 30% chance of rain today. The next one might say it's a 45% chance. Someone else might say it's 20% chance. They all disagree because they're all using some bit of their personal opinion and knowledge to make that adjustment. Okay, so subjective probability is based on personal opinion. Like an example I said would be the weather. Okay, classical probability. So classical is what should happen, what we would expect. So if I flip a coin, there's a 1 in 2 chance of heads when we flip a coin. Empirical. Okay, I always remember empirical is based off past experience or evidence. So I always think the E's go together. That means I'm not just looking at what I would expect, I'm looking at what's happened in the past. So I have a coin, I flipped it 10 times, and I got heads 8 of those 10 times. So there is an 80% chance of heads. So it's based off what I saw occur. Any questions there? Number 16. So, a life insurance company. We've seen this one a couple times now. We had a class example, you had a homework problem, it's on your study guide. So maybe it will be on your test tomorrow. I think there's a similar one on your other second study guide. So, we have basically two outcomes here. The person could live or they could die this year. Right? We need to look at the X and the P of X. We are looking at it from the perspective of the life insurance company. So if the person lives this year, what value does the life insurance company get? $300. They get to pocket that $300 if the person lives. And the probability the person lives is okay. But if the person dies, then the life insurance company has to pay them $250,000. So they are losing money. Except they didn't lose all $250,000 because they still have the $300 payment they received. So they end up losing $249,700. And then what's the probability of that happening?
0.00045.
It's just 1 minus the probability of it. Okay, so then it asks for the expected value. Expected value is the same thing as mean. So you could even just make an XP of X column. So if you multiply those, and again, I know this is the mean because it's on my formula sheet in a probability distribution. The mean is X times P of X. So the mean, you add all those up, and we get $186. So life insurance company expects to profit $186. Now, does that work if they only insure 10 people? No. But if they are insuring hundreds of thousands of people, then they could expect on average $186 per person. Number 18. So we have the probability a patient who visits the ER will die within the year is 0.05. Okay, this is binomial because there's two outcomes. Either they live or they don't. On all this A, B, C, D, all of those parts, there is a fixed number of trials. And those would be independent. So I'm just talking about patients who visit the ER in general, not just at one particular hospital. Okay? So if I look at B, what's probably that fewer than 2 of 25. So my total number is 25. Fewer than 2 means it could be 0 or it could be 1. Does our table go up to 25? No. So we have to go to our formula sheet and do the binomial formula. So it says N, choose X, P to the X, 1 minus P to the N minus X. So we do that for 0 and 1. So if we get those, does everyone know how to enter that into their calculator? When you type it all in, you should get 6424. If anyone needs help entering that, let me know. Remember, you have to do a parenthesis, like 25, then go into your math, probability, NCR, and then type your 0. you could put in each individual piece. So part C says the probability that at least 2 of 25. So we still have 25. At least 2 means it could be 2 or 3 or 4, all the way up to 25. So you could calculate all these, or you could realize that's the opposite of what I found in part B. So if we subtract those, we get 0.3576. D. This one kind of changed it. So we have, now we're talking about 10. It says at least 8 of 10 will not die. So there are 2 options for doing it. One, since we're talking about the probability of not dying, what is the probability of not dying? So then at least 8 means it could be 8 or 9 or 10. So this is probably the easiest approach. So you just go to your table, because we do have 10 on our table. We go over to the 0.95 column, and we're going to go down to when x is 8, 9, or 10. And add those together, and we get 0.9884. The other way of thinking about it, if at least 8 do not die, so if 8 don't, that means 2 do. If 9 don't, that means 1 does. If 10 don't, that means 0. So you could have gone to the 0.05 and looked at 0, 1, and 2. And you'll notice it's the same 3 numbers. So you could have added those and you get the same answer. So 2 ways to think about it. Part E. In a random sample of 1,000 ER visitors, how many are expected to die within the next year? Expected value, that's the mean. This is a binomial. So mean of a binomial is n times p. We have 1,000 people. The probability of dying is 0.05. So that gives us 50. Standard deviation for a binomial is the square root of n times p times 1 minus p. So square root of 1,000 times 0.05 times 0.95, and we get 6.8920. Oh, I think that's someone else. Oh, no problem. Thank you. Are those okay? Number 21. So, if I ask you to calculate it, that means by hand. So it's n, choose x, so 4 choose 1. P is 0.3, so it's p to the x power. 1 minus p to the n minus x, so 4 minus 1 is 3. And then you guys know how to plug that in. Just put it in your calculator and you get 0.4116.
I don't know what I even did to get my answers.
You're not supposed to. If I say calculate, you have to write it out. Do you guys?
I can't find my thing.
Ella, where did you?
Ella.
You might want to talk to Ryan Moss.
Uh-oh.
Talk to Ryan Moss. He probably.
But I knew I should have signed his thing.
Well, he was mad that he couldn't find his, so I think he started taking other people's.
That is not what Jesus teaches.
I think someone took his.
Well, because we were looking for it for like half the first hour, and we said it was like on like the board where like the banner hangs over on the other hallway, and it was not there, so he got mad. Sorry.
Alright, so if you guys know how to plug that in. And if I say calculate and all you do is write down the decimal, you will lose all the points. So if I say to calculate, I'm expecting you to write this so I know that you knew how to do it. Or I might give you like an end value that isn't on your table, so that you can't do it by the table. Grant.
I didn't have the calculator.
So,
You can.
next one, n choose x, p to the x, 1 minus p to the n minus x. And you guys know how to find these on your formula sheet as well, right?
Yes.
24. Alright, according to a poll, 70% of Americans bet on professional sports. So the probability they bet is 0.17. Approximately 48.4% of the adult population is male. So the probability of male is 0.484. So A, the probability that they are male and bet, so we have to assume these are independent. So 0.484 times 0.17, because you use the multiplication rule for independent events. You get 0.0823. B, the probability that they are male or they bet. So you have to go to your formula. The probability of male or bet is the probability of the first minus the probability, plus the probability of the second minus the probability of both. So that would be 0.484 plus 0.17 minus the answer we got to part A. And if you do that, you get 0.571. We okay?
Oh yeah, my finger hurts. Oh wait, I stopped. Wait, what? I stopped it. When?
Then problem 25, last question we had on this. So, the probability that the household is in the northeast is 0.179. 5.4% earn $100,000 per year or more and are located in the northeast. So the probability they earn that amount and are in the northeast is 0.054. We want the probability that they earn that amount given they're in the northeast. Okay, a couple ways of doing it. You could either use the multiplication rule or the conditional probability, either way. The probability of E given F, if you look on the formula sheet, is the probability of E and F divided by the probability of F, so the probability in the northeast. Or you could use the AND formula. It would be the probability of being in the northeast times the probability they earn that given they're in the northeast. Either way, you're going to plug in your numbers. And if we divide, we get 3017. If you plug them into the AND formula, you again have to divide to get the piece that we're missing. Same. Questions there? Okay, so now we are on to review B. Woo! Making progress. So problem number 1. Okay, the sample space for winning and losing. So we're rolling 2 dice. If they add up to a 5 or a 9, you win. So you could win if you roll a 1 and a 4, or a 4 and a 1. If you roll a 2 and a 3, or a 3 and a 2. Those would be the only things that add up to 5. Things that add up to 9, you could do 3 and 6, 6 and 3, 5 and 4, 4 and 5. You lose if you get a 4, 6, or 8. So to get a 4, that's 1 and 3, 3 and 1, 2 and 2. To get a 6, you could do 1 and 5, 5 and 1, 2 and 4, 4 and 2, 3 and 3. To get an 8, you could do 2 and 6, 6 and 2, 3 and 5, 5 and 3, or 4 and 4. Is that okay? And then part C, the probability you lose on the first roll. So we did a few dice examples. And remember, if you have 2 dice, there's 6 options on the first, 6 on the second. So 6 times 6, there were 36 total combinations. So if we count, we lost in 13 of those. So 13 divided by 36. Alright. 3B. Okay, so let's look at A first. On 3A, probability that we've reached base 3 times. So he makes it 30% of the time. We would assume the 3 hits were independent. So if you multiply those, you get 0.027. So B, when I say the probability he will not make it in at least one of the next 10. If I wanted to find the probability that he makes it in all of them, what would you do? Similar to A.
1, 3, 2.
So the probability that he doesn't make it at least once is just a complement. So it would be 1 minus the 0.3 to the 10th. So we see it is extremely likely that he doesn't make it at least once. Questions there? Number 5. Alright, so we are looking at this table. So 5B, we want to be in the 914 to 2437. I feel like it would help if I could show this a little more. Okay, so to be between 914, so we can't be under it, up to 2,437. That means it can be either any of those, so you add up those 4 numbers and you get your 5661, and it's out of everything, the 14,951. Is that okay? So for part C, we want less than 1524 and unpaved. So under 1524 tells me I have to be here. Unpaved tells me I have to be here. So then you add those 3 numbers, and it would be out of everybody. Sorry, not the total. Don't add the total. Add those 2 numbers out of everybody. All right, D. More than 2,437 and paved. So we have to find more than 2437. So that means it could be just but I think I have a mistake on mine, don't I? More than 2437. So that's only the top category. And paved.
No, that'd be
You don't have the over 30, 47.
Yeah.
There's another column.
Oh, sometimes I have mistakes on mine and I refix it on your copy, but I don't retype my whole thing. Does that make sense? Sorry. So, let me borrow one of yours to show for a second. It's like, wait, this doesn't add up. Okay. So, more than the 2437 and paved. So, you add up those two out of everything. E. So paved, given it has more than 1523. So my given, more than 1523, that tells me that's all we look at. So I'm only looking at those numbers. Out of those, I want the paved. So my denominator is just what I get when I add those up together. So that's the 2043. My numerator is all the paved ones. I really encourage you guys on the test, make sure you are showing me the fractions you're dividing. When I was coming around, I looked, a lot of these, you guys only had a decimal, but I would still probably make this a 2-point question. You know, one for having the correct denominator, one for the correct numerator. So make sure you're writing that down so you could get partial credit if you do make a mistake. F. This time the given is the unpaved. So I only look at my unpaved. My denominator then is the 9805. My numerator, I want less than 1524. So less than 1524 means it has to be those two. So I add those together, it's 9643, and then we divide those. G, it's unpaved knowing it has less than 1524. Knowing is like a given, so I know it's smaller than 1524. Okay, and out of those, I only want the unpaved ones. So my denominator was those numbers added together. My numerator would be the 9,643. Do you guys understand where all my numbers came from here? Number 6. So this is very similar to that other question with the life insurance. In a game of roulette, a player can place a $5 bet on number 17 and have a 1 in 38 chance of winning. If the ball lands on 17, the player wins $15. If not, the casino keeps the 5. What is the expected value to the player? So we can make a table. Expected value means the mean. For a probability distribution, that means the sum of your x times p of x's. So we need our x, p of x, and then we'll multiply them. So our options are they either win or lose. All right. If the player wins, how much money do they get? Right. They get 15, but they paid 5 to play. So if they win, they're only actually making a profit of 10. If they lose, what do they lose? The 5 they paid, so that would be a negative. All right, what is the probability of winning? 1 in 38 that was given. So losing would be everything else, so 37 out of 38. So if we multiply those, together. And the expected value, if we're talking money, 2 decimal places would be sufficient. So if you play, you should expect to lose $4.61 on every turn. Now, is that true if you play 1 round? No. But if you were to sit and play 100 times in a row, you would expect to lose on average $4.61 every time. Casino games are not in your favor, guys. Just gonna throw that out there. Important life lesson.
Yeah, it's spade.
Spades
Is
is
it good?
Like 99% of gamblers quit before they win big.
Uh-huh.
That's interesting.
Alright, so problem 8. Here.
You can throw it away. No, I'm giving it to her. That was the deal. Take it.
So these say calculate. Are these the same ones I had on the last question? I think they're different. Alright, so you have to show what you're doing. Did we have problems plugging these in for asking about all of the ones that we calculate?
Honestly, sometimes I thought I did.
Let's try it.
Sometimes I'm good.
Is
I'll
It's
lie.
really
This is the
okay.
only thing I'm good at.
It was n choose x,
I won't be humble about it.
Yeah.
guys.
A is the
P
same.
to the x,
B is different.
yeah, 1 minus p to the n minus x. So plug it in. You do parentheses, 4, math, probability, NCR, 1, close that parentheses, 0.3 to the first, 0.7 to the 4 minus 1 is 3.
I don't know what I did yesterday. I got 2 different answers that
Uh-huh.
were both wrong
No.
for this exact problem. On the
Interesting. Did you guys get it that time?
She used to. You be quiet.
It was Abigail both times.
I didn't ask for those to be put up there. This is the other one. I don't know what she's doing.
Stuff today.
Just kidding, she's cooking. I was joking.
If you do this one, you should get 0.5625. If anybody's having trouble getting those on a calculator, let me see what you're putting in so I can help.
I'm not going to.
Couldn't you not put in the centerpiece whenever
Where
it's
did you
just
get
zeros? It's
So
all
she's
good.
not taking you
Ella.
as you stink.
Yes.
Someone did not say that. Dude,
Alright.
I'm about to commit physical violence.
3 more here. Problem 10. So, mean and standard deviation of a binomial. Mean is n times p. So that would be 11 times 0.05, and you get 0.55. Standard deviation is the square root of n times p times 1 minus p. So that's 11 times 0.05 times 1 minus 0.05. And you get 0.7228. Is that okay? And problem 11. Last one. Okay, we're trying to decide if it's empirical or classical. Empirical is based on evidence that we saw. Classical is what we would expect to happen. So A, if you roll it 5 times and you got a 1 3 times, or sorry, 2 times. So is that based off what I would expect from rolling a die or what I saw? What we saw. So that's based on the evidence. So that's empirical. B, if we roll it, we expect a 1 to appear 1 out of 6 or 16.67. So that would be classical. Couple other terms that you might need to make sure you know before this. Independent. What does that mean? Right. The occurrence of one doesn't change the occurrence of the other. What is mutually exclusive?
Can't have them at the same time.
They can't both have no overlap. What's a sample space?
All the things that can have
All the things that can happen. What's a complement?
1 minus.
1 minus, the opposite. What is a binomial?
Something that
It's
has a
when
set number.
set number of
Oh, go
trials.
ahead, go ahead.
Two possible outcomes, and they are
Independent.
independent. What's when I talk about a conditional probability? What's that?
Can only happen if something else happens.
Right, that's when we see those givens. The probability of something given that the other occurs. All right, are we ready for this test tomorrow?